Okay, welcome to this session. I'm going to talk about Open Telemetry. It's part of the Enterprise Edition and will be in 8.4. So, as in contrast to the last talk that was very kind of super advanced and stuff, this is more very down to earth, very practical stuff. Just mention that the 8.4 Enterprise Edition will be the 8.0, except for these two red things that Øystein talked about, the JavaScript and the Open Telemetry. Yeah, now. I think this audience probably, you all know about Open Telemetry, right? Anybody who doesn't know anything about Open Telemetry? Don't dare to do that. This is typically audience for it. So it's a standard, it's a very popular standard, very heavily used for observability. And it is a standard, it has its terminology, its specification, its APIs, libraries, all of it, done in a very good way, I think. And what I will present here is our implementation to date about what we do. We do follow the standard very to the letter. So we kind of use the terminology, we have used the APIs, we have used everything. We have implemented, there are kind of three main elements in this standard. There are the traces, the metrics, which we have implemented, and then there are logs. We have not done logs, at least yet, because we need to figure out, okay, it's essentially the same error log, or what to do? Should we have just send everything we have in the error log to this, or do something else? I'm not sure. But anyway, we have implemented traces. So this is the architecture roughly of Open Telemetry. So MySQL will then, in this case, be on the top here as an application. Then there can be a collector, optional, or you can send directly to the backend. So both things are supported. The collector can do certain enrichment. It can, for example, send to several places and stuff. It can do there's some functionality in this middleware layer. And then there is backends. There's a lot of commercial and open source backends existing. Typically, there are some backends like Geir, Prometheus. There's a lot of them, and then you have typically on this backend you have some visualization to show graphs and stuff. That's roughly the architecture. So we are supporting traces and metrics in 8.3. That's also what will be there in 8.4. We support all the Enterprise Edition platforms on Windows and stuff. It's supported by all the MySQL connectors, and this is for traces. You install it as a component, file component telemetry. You can overall enable and disable metrics or traces independently. And you can decide where to send traces or metrics. They can be sent to different places. They have different endpoints to the same thing. One way to introduce you to what we have done is to show you what you can configure. This is about enabling metrics. There is also one I will show you for traces. For metric, you have 3 frequencies. That's kind of potentially up to 3 background threads that will run. And at the decided frequency, 10 seconds, 60 seconds, 0 means disabled. So in this case, there will be one running every 10 seconds, another every 60 seconds, and that's for metric. So that's when we read the values and send it to the backend. This is configuration for tracing cache internally. So there are some you can define how much batch size, queue size, and schedule delay, some configuration of the traces. So traces are kind of stored for a while locally and then sent when the buffer is full or in a certain interval. Then there is essentially a lot of setups for the communication, ciphers and SSL and these things, how to communicate with the backend. There's the endpoint, whether you have compression or not, and things like that. This is the second half of configuration. Is there more to say? Specific. One important thing is resource attributes. You can define something instead of a generic server. You can say some attributes of this server. There's a kind of key value pair type of thing. So you can say this is my production server, so and so that it's easy to spot in the trace that this is exactly this server we're talking about. Production, testing, and things like that. You can decide whether you want to include the query text or not. That's mainly for an option to turn it off if you want to not expose the queries, kind of thing, more a security type of thing. That's about it. So yeah, not that much to configure. That's only to set it up and to point to the right places.
Is the tracing designed so that if the endpoints are not there, basically it will just drop things if it has to, rather than not affect server performance?
Yes. So the overall goal for traces and metrics is that they have a little bit different strategies defined, I think, partially by the standard how to deal with those situations. But it gives up and it actually flushes the cache in traces. So and continue and try again later. And you will then lose some traces, but it will not stop the server or slow it down or things like that. So what is the point about traces? I guess you all know this, but the idea is to be able to follow kind of an activity, so to speak, through the application stack by using a trace ID and a span ID. I will mention this. And that's essentially the whole idea. So a connector to MySQL will typically then add information about this is trace ID so and so, and the server will pick it up and do the right thing about that trace ID and then report to the backend on this trace ID, and then you see the bigger picture from the backend. So what is a span? It's a unit of work, and they can be hierarchical. So you can have subspans, so that you have a trace consists of several spans, and then each span can have sub-activities in that span. So it's a way to present the overall activity. So a span has a name. As a parent span ID can be empty if it's the top level span. And for root spans, it has a start and end time, context, attributes, span events, and span links. So we have not really used all of this that much. We have not been using span events so far. We have links implemented. Yes, I think it's best to go to this. It's just me trying to explain this in a perhaps too complicated way. This is simply just saying that this is a client application in something, and it talks to two different servers. This can either be the root, but it can also be part of a bigger chain, right? So it gets, this is in the case the trace ID 10, which is covering the whole thing. You see that trace ID 10 is the root of this span here. So it sends this information, trace ID 10, for example, span 6 to the server 1, or perhaps it even already sent some client activity to the backend already. That's why the green is the root of this thing. And then there are the subspan created here, potentially, that report to the backend. So same thing will server 2 reports its activity to the backend, and then the backend is here. We will construct the overall tree of activity. This is how it works. Are there any questions so far? Is this probably non-stop? So what's our support? We have implemented support in all the connectors. So a connector can then send, so if you're writing an application using a MySQL connector, you can send the trace ID, the span ID to the server. It's passed as part of query attributes over the MySQL protocol. MySQL server understands the incoming trace context. When no context is provided, then a new context is created by the server.
So Geir, so where you don't provide the connectors, say Go or the other languages as well, there's a change in the MySQL protocol or parameters passed in some of the. How do you handle that then?
They are simply query attributes.
The query attribute. Okay, so that's what you modify the query attributes, and that's enough for then the server to know I need to do something special based on that value.
Right.
My collection here might be a little bit fuzzy, but that you chose to use query attributes instead of, I don't know, passing it on a comment doesn't require an extra round trip between the application and MySQL server.
I don't think so. Just add it to the normal.
Yeah, because if you use a MySQL command line, and I want to send one query, then how do I include the query attributes in the single query that I want to send on the command line?
Yeah.
Because the next query I don't want to trace, but that one I do. How do I do that?
I don't know the answer to that. Anyone else?
For the query.
So it's like a hint or something?
Yes.
I'm just okay.
Yeah, actually I will show that.
Okay.
Yeah.
Thanks.
Thank you.
Yes,
You said it. We have implemented 3 spans in the server, so that's kind of our decision what to trace. The control is simply when you enable and disable trace, you send a message, I know enabled, I know disabled, so that you have a way to understand in the, okay, this was actually the beginning point of this thing. We have session. So this is, we are tracing session. The thing is with session, they are not linked to the trace. They are separate in MySQL. This is a design decision, and you could choose to do it differently, probably. But I think the main reason here is that you only send the trace when the session is closed, and there is very little connection between kind of creating and closing sessions and active in many cases active.
You already said the trace when the session's closed, but I can have a session open for 6 hours and do 100,000 queries.
Correct. So then you will only see the session in that at the end. So an alternative design would be to both log the start of the session and the close of the session.
Okay.
The decision that has been made so far is that it will be shown when you close the session. That's the decision that was made in this process. Other decision could. So what we log here is essentially this, but all session attributes, but it's actually the same as we have in session connect attributes performance schema table. So we pick that information, add some additional timestamping around it, and send it. So it's kind of, if you're familiar with performance schema, you will see the same information. So it is a statement that is actually traced correctly or according to span IDs and subspans and stuff like that. So that's the most important thing. So each time you have a query, you will we send send the trace for each value. And this is from the same as event statement current, or this cluster table. There are current and history and contain the same information. So that's a very long list of many, many more. I don't remember how many. It's like 30, 40 attributes sending for each statement. This is trying again to illustrate some of this. This is a client that does first a connect, a disconnect, and send a query and a disconnect. So that's the application flow in this example case. It shows that it creates a session span, and it creates when you actually disconnect. But it's in the background. We have the start time of the session. So when we send the trace, you will see both the start and the end. But it's not visible in the backend as a trace until the session.
Just send them separately as separate messages, effectively.
Hmm?
Don't send them as separate messages.
No, we could, so as I said, we potentially could have done two different, one when you connected and one when you disconnected. Yeah, but we maintain a link from the statement span to the session span, so you can identify the session. If you have statements that call themselves, you will get subspans according to the standard. That's about it. So this example could look like something like this. We have a separate trace ID for that generated by the server for the session, since we are not linking it to the trace. And then this is the trace created by the client or somewhere that have then three span IDs, and this is the server span statements with one a hierarchy potentially on it. So this happens during connect. This is the query statement, and this is the connect statement. Generates these traces. That's what I plan to say about traces. I will talk about metrics. What are there anything about traces that you want to understand? Yeah?
What about MySQL router?
The router. Doesn't support it.
Yet.
Can you say anything about it? Will you talk about that later or no?
No.
But
It's,
how
I've discussed that today with Jan.
Right. So probably something will be coming as part of the NVD cluster story overall,
Yes.
I guess.
Eventually.
But now this is connector and server. No, neither the shell at the moment.
You don't connect to the shell.
Yeah, metrics. So metrics has their own terminology in Open Telemetry, and I've got you some terms here. There are many terms. A measurement captured at runtime, a metric event, the moment of capturing a measurement, a value, timestamp associated metadata for this. A meter is a group of metrics created by the meter provider. In our case, we are a meter provider, so we will have defined meters in this model. A metric instrument that has a name, a kind, a unit, optional unit, and a description. This is all kind of standard terminology type of, not something we have invented. There are different kinds. We only have we have counters essentially, and then you have a metric exporters and metric data for consumer. So we are a metric exporter in this model. MySQL we have essentially it's all the show global status variables that are exported. There are 474 of those at the moment. You can look at the meters defined by looking at this table, set of meters. I will show that in a moment. And yeah, essentially they are observable in this set of metrics, and you can see all the metrics. It's an alternative view. You can configure them. You can turn per meter. You cannot configure them per metric, but per meter, on off, for example. Everything in show global status. And meters, this is the meter table, or I think there are altogether 15 meters that can be turned on and off. And they can be defined the frequency per meter, not per metric. And this frequency is kind of rounded up to these other frequencies. I can explain a little bit about that. But essentially, you have up to 3 groups of frequencies. And you can choose which meter goes into what group. So that's the configuration of meters. So this is back to these frequencies that you defined in the configuration. So you have defined 10 seconds, 60 seconds, and disable this one. And then this meter frequency will be rounded up to the next, the higher group of this. That's how it is configured. So this is the metrics. So there's a performance schema table. You can look at those. It's essentially the source variable in MySQL. And then there is a type. And we only have 2 types. You have either an async counter or an async gauge counter. This is always kind of incremental counting. It always goes up to an incremented way. And this can go up and down. The value as this has right now when you ask it. And all these counters are async in the sense that we see the value when we ask it about this value and then send it directly to the backend. So we never see real-time values. There will be some latency that you define about the frequency, etc. That's probably it. Just mention a few things. Yeah, on the metric side, there is no buffering. It's kind of there's a thread reading all the variables and sending them immediately to the backend. For some reason, it takes a long time. You will get timeouts and everything. It will just. I don't remember how long it will. But essentially, let's say if it's delayed, it will just until it's done, and then it will start a new cycle afterwards. If it's kind of takes more time than the frequency. That's it's asynchronous. We don't export in real time. There is only one background thread per metric, so there's no conflict in threads. And they are not protected by mutexes, so in general at least. And so occasionally you might see garbage, but it is unlikely. And this is simply just because it's probably not a big deal. You see a strange value and it's garbage, and in that case, but it has a lot to do with performance, so you don't. Kind of try to do this in a way that has minimal impact on payload, like that's been an important thing. It should not kind of affect the server in any negative way, either if the backend doesn't respond or by starting prolonged stuff. that's essentially the story.